In this video, I will showcase the concept of dilations. The definition of a dilation is a transformation that produces an image that is the same shape as the original, but it is a different size. In any problem including a dilation, there must be a scale factor and a center of dilation. These two items are necessary to find the solution of any problem involving dilations. The center of a dilation is the fixed point that both the figure and new image originate from. This means that all the lines drawn from all points and their prime should meet at one single point. The scale factor of a dilation problem is a ratio that gets applied to the original image in order to create a second one. A good hint to know is, if the scale factor is greater than 1, the image is an enlargement. If the scale factor is between 0 and 1, the image is a reduction. And if the scale factor is 1, the figure and the image are congruent. An important thing to remember is that dilations, rotations, reflections, and translations are all different things. A translation is simply a slide that the figure takes to get to a new part of the plane. A rotation is turning the image along a fixed point, and a reflection is a flipped image of the original figure over a set line. Here's an example of a dilation. A triangle with vertices 2, 1, 3, 5, and 8, 4 will be labeled triangle ABC, and a second image with vertices on 2, -7, 4, 1, and 14, -1 will be triangle A', B', C'. Now, in order to find the center of dilation, we must identify which vertices the original triangle corresponds to with the dilated triangle. As they are similar shapes and labeled correctly, these vertices each correspond to each other. Now we can draw a straight line through all the corresponding points, which all intersect at a certain point, the center of dilation. We can calculate this center by finding two formulas and setting them equal to each other. We will use the A's and B's. Since the A's are vertical, we'll look at the x values to find that the equation is x equals 2. We then find the slope of the B's, and take an already known point and plug them into point-slope form, and simplify to slope-intercept form. Then we plug x equals 2 to find the y value, and we get 0.29. Next, we must calculate the magnitude of the dilation. This is done by finding the length of a line segment from the new image and dividing that with the line segment from the original. An example we'll do is A', B' divided by AB. AB is root 17, and A', B' is root 68. If we plug this into the equation, we get that the magnitude of the dilation is 2. So this means this specific problem has a center of dilation at 2,9 and a scale factor of 2. Dilations don't just apply to shapes. They can also apply to line segments on a graph. The same method is used to find the center and magnitude of the dilation. In this example, the question is asking where point C will be dilated to. Write the equation of point-slope form, and then simplify to slope-intercept. Then set the equations equal to each other. You should get 0.11. Now that the center of dilation is found, we now need to calculate the scale factor, which we can do by using distance formula. We first subtract the original coordinates from the new figure's coordinates to find the vector. Then we square both numbers and add them together, and then finally square root the single number. Now that we know the scale factor is 3, we can use this with point C. We subtract the x values from C and the center of dilation. Then we multiply by 3 and add on to the center of dilation to get C'. So, in conclusion, the main points of focus to take from dilations are: dilations are a shift and resize of an original image, so it's not the same as a reflection, rotation, or a translation. You use a system of equations to find the center of dilation. You find the vector by subtracting the original figure from the new image. And you can check your answers by making sure the scale factors are the same and the lines can be drawn to the same fixed point.